Okay, let's talk about the derivative of the natural log. We've got some basic review of derivatives here. We got the power rule, some basic review, and then here I have some properties of the natural log, and I have to remind you of something. This is actually a little typo. This should just be the natural log of 1 is 0. The natural log of 1 is always going to be 0. And remember that if you have the natural log of a times b, you could separate that out as natural log a, natural log b. Remember, if you have an exponent inside the log, you can move it out in front as a coefficient, and if you're dividing, that's like subtracting two separate logs. So, some basic review. Let's talk about the derivative now. Let's go to the next page. Okay, here's the thing with the natural log of x. The rule for the derivative of the natural log of x is that it is simply 1 over x. This little notation here accounts for something that we're going to learn soon called the chain rule, which means maybe there's something more going on inside there. I'll talk about that in a little bit, and we'll address that a little bit, but basically what I want you to just get for now is that the natural log of x is 1 over x. Okay, and if x is more than x, let's say it's like a function, then we have to also multiply it by the derivative of whatever that function is. So let me give you an example. Okay, here it says find the derivative of each function, use y prime. All right, let's just look at this one. The problem with this first problem is that inside here we have a function inside a function. So this gets us into something called chain rule, but it's actually super easy if you just kind of follow this basic step. What I'm going to do is, instead of having an x cubed in here, I'm going to think of this as the natural log of something else, some other variable. Let's just call it u. Okay. Well, that means I'm going to have to say we let u equal x cubed. No big deal. We let u equal x cubed. This is just a simple u substitution problem. Well, now if I have the ln of u, that's easy. That's the ln of x is 1 over x, so this must be, if I do the derivative, it just must be 1 over u. But what we're saying here, and what this is true in all functions, and we're just kind of seeing it for the first time, is that, well, if something is a little bit more complicated, if that u here is a little bit more complicated, we have to remember to multiply it by the derivative of whatever that x is, or in this case, whatever that u is. So that means we need to remember to multiply it by u prime, or the derivative of u. Well, that's not that hard, because we actually know what u is, and we could take the derivative of this so easily. What is u prime? Well, it's 3x squared. All right, well then let's just plug everything back in. I have a 1 over u. I know that u is x cubed, and I know that u prime is 3x squared. So this is like saying 3x squared over x cubed, and this can reduce, right? I could take 2 x's out of here, 2 out of here, and so really my derivative is just 3 over x. Okay. I know there's a lot of things to think about, but all we're saying is when there's a function inside a function, we have to remember to multiply by the derivative of the inside. This is basically chain rule, something we're going to spend a lot more time on later with a lot more complicated functions, but I just want you to kind of get a brief introduction to it. Another way that you might see this u prime written is du. So instead of u prime here, I could have written du and du. And I'll do that notation on the next one just so you could see. That's actually usually how I write it, because that leads way to something else that we're going to do called implicit differentiation. So let's take a look at y equals ln of x to the 4th power. Okay, this is technically a function inside of another function. So I'm going to make this simpler. I'm going to take the thing on the inside, and I'm just going to replace it with a u. What does that mean? Well, that means that u equals ln of x. Well, this is no big deal. I'll just take the derivative of this. That's easy. This is 4u cubed. But remember, when this thing is more complicated than just a simple variable, we have to remember to multiply by the derivative of u, or in this situation, I'm going to call it du. Same exact thing as saying u prime That's all it is. It's just another way of saying the derivative of u. Well, and just to make sure we're clear, we've always been doing that. If you think about it here, even when we were taking simple derivatives like this, I really was multiplying it by the derivative of x at the end, if you think about it. Because what is the derivative of just x? Well, it's 1. But you don't have to write times 1 every time, right? That seems redundant. So we've actually been doing this. We just haven't had a situation where it was relevant. And now that we have functions within functions, it's becoming relevant. So we can simply take the derivative of just u, and that would be derivative of ln x, which is 1 over x. And so now I could plug everything back in. I know that the derivative is going to be 4. What was ln x? Well, what was u? It was ln x. And then what is du? It's 1 over x. And so you could clean this up a bit. You can make it 4 ln x cubed over x. And now you have the derivative. Okay. I know it's a lot to think about, but really it's a pretty simple concept. You just got to remember that when you have a function inside a function, you're going to have to use this kind of chain rule is what it's called. But if you just use u substitution, it's really simple. Don't worry, we'll play with it a lot in class. Let's do a couple more here. Okay, this one, I want you to remember me to do this one in class because this actually involves something different. We haven't yet seen derivatives of quotients or things being divided by each other yet, so I want to do this one in class with you, just an introduction to another rule. I don't want to overwhelm you right now. So we'll do this one in class. Let's go to the next page. Okay, this is going to get real interesting real fast. Now look at what we have going on here. We actually have t squared, which is a function. I'm going to put parentheses around it so we can kind of see it. So we have t squared inside of the natural log function, inside of another natural log function. So this starts to get a little hairy, but it's really simple if we start just thinking about this in terms of u substitution. The first thing I'm going to do is I'm going to take this most complicated part and I'm just going to call it u. And so that means I could just say, hey, this is just saying the natural log of u. But remember, over on the side, I got to talk about what that means. I'm saying that u equals the natural log of t squared. All right, before I do any more work, let's talk about what this is going on over here. We still have a function inside of a function. So I can actually do another substitution. I could say, hey, let's let this t squared right here, let's let that be something else, and what comes after u in the alphabet is v. So let's just say v equals t squared. So now I really have that u equals the natural log of whatever v is. And so I can start simplifying this thing out, and this is kind of why it's called chain rule, because it kind of has this like chain reaction effect to it. Doesn't really matter what order you do this in. We could pick whichever order we want, but I like to go to the most simplest thing first and then kind of work my way back. So what is the derivative of v, or what is dv? Well, that's easy. It's just 2t. And here's where you can start seeing, if you really wanted to, you could put a dt here, but the derivative of t, if t is as simple as it gets, it's just 1. So even if I put dt here, well, the derivative of t is just 1, so I don't really have to worry about that. All right, and now let's do this one. Well, what's the derivative of u? Well, du, we know how to take the derivative of natural log. That's just simply 1 over v, but remember, v is more complicated. It's something else, so I'm going to have to multiply that by dv. Okay, let's go back to our original problem. See, we're having this chain effect. You'll see here in a second. So if f of t is ln of u, then f prime of t equals 1 over u du. No problem, because I have some things to substitute in for u and du. So let's go ahead and just substitute in what we have. We got a 1 over u. We know what u is. We could do either one of these. Let's do this one actually for now. Let's do the less simplified version just so I can kind of show you how this is going to work. So you got u equals ln of whatever v is times du, and we know that du equals 1 over whatever v is times whatever dv is. And so now we could substitute in again. Okay, so I have everything in terms of v. Well, that's okay as well because I know what v and dv are, and so I can plug everything back in and then simplify. So 1 over the natural log. What is v? Well, v is really just t squared, times 1 over v. Again, v is just t squared, times dv, which is just 2t. So we could kind of simplify this a little bit. For one, this is kind of like saying 2t over 1, and so I'm seeing that I can take away one of these t's and one of these t's. Other than that, I'm just gonna multiply whatever's left. So I got a 2 on top, and I have a t times the natural log of t squared. Pretty fun problem. Lots going on. A lot of practice with the chain rule there, and we'll see more practice with that later. But I just want to kind of give you a brief introduction to it. This is definitely a little bit more advanced problem than I'm expecting you guys to be able to do at the time. But I just want to show you that even though we have functions inside of functions inside of functions, it's not a problem. It's still manageable. It just takes a little bit more organization, a little bit more work, but it's very doable. So I want you to try examples 3a and 3b on your own. Remember, just substitute in for these things inside the parentheses, and I think you'll be able to handle it. Try them both, and then pause the video and then check back when you're ready to check your work. Alright, so I've got both of these worked out here. Real quickly, just substituting a u. That means u equals x cubed plus 1. The derivative of that is just 3x squared. You drop the 1. So the derivative of ln u is 1 over u times du. Then I just plug everything back in. 1 over x cubed plus 1 times 3x squared. 3x squared over x cubed plus 1. We can't really simplify that anymore. Remember, this is an old thing, but there's kind of imaginary parentheses there. There's nothing to cancel out here because you have to add that 1 first. Okay. Here again, substituting u for sine of x, so u equals sine x, therefore the derivative of u would be cosine x. So what's the derivative of ln u? Well, it's 1 over u du. We're seeing a pattern here, right? And then I just plug everything back in. The u is sine x, and the du is cosine x. So we actually end up with a cosine x on top, a sine x on bottom. Well, that's actually a known trig function. That's the cotangent of x. So interesting enough, there's some relationship between the natural log of sine x and the cotangent of x. Okay, one last page. All right, for these guys, don't get overwhelmed looking at this. It looks crazy, but you have to first remember that this is all the natural log of all these things, and there's rules for natural logs. We talked about them on the first page. So you're going to expand this thing out according to the rules of natural logs, and you're going to see it's going to get a lot simpler. Remember, anytime you're multiplying, you can add. Anytime you're dividing, you can subtract. Exponents, you can move as coefficients, and technically this square root could be written as a 1/2 exponent. So let's give it a go. Alright, so the first thing I'm going to do before I even start to take the derivative of this thing is just separate it out. Remember that I could write this as the natural log of x plus the natural log of x squared plus 1 squared minus the natural log of the square root of 2x cubed minus 1. Okay, and I could simplify even more than that because this square root is really a 1/2 power, and so I could write this as the natural log of x plus 2 times the natural log of x squared plus 1 minus 1/2 the natural log of 2x cubed minus 1. Okay, now I can take the derivative. This is not hard. Once I've broken it up, it's not hard. It looks crazy hard, it looks crazy confusing, but it's actually really easy. Let's go for it. The natural log of x, well, let's first go ahead now here and just say that if this was f of x, then the derivative would be f prime of x. The first thing is just going to be 1 over x plus, I'm just going to put a 2 there, times. Now we can think of this as u substitution, or we can maybe just remember to do the chain rule. It's up to you how you want to do it. If you really want, you could say, for example, you could say, okay, that's u, and we could say that's v. And so we could just quickly say, okay, the natural log of u is going to be 1 over u, but I know there's more to it than that, so I'm going to also say times du minus 1/2. And the natural log of v, the derivative of that, is going to be 1 over v times dv. So now I could do a little side work. And I know that u equals x squared plus 1. Therefore, the derivative of u would equal just 2x. And I know that v equals 2x cubed minus 1. And therefore, dv equals 6x squared. So let's plug it all back in. We get 1 over x plus, I'm just going to put this 2 on top, over, what is u again? Well, it's x squared plus 1, and du is 2x. So I'm going to put that on top, because I'm multiplying, it goes on top, minus, on the bottom I'm going to have a 2, the v is 2x cubed minus 3, and on top it's going to be dv, which is 6x squared. Okay. At this point, you could simplify some things. I'm not really going to bother with that. The point is to show you that something super complicated like this can be broken down, and you can take the derivative simply. This is the derivative. It may not be simplified all the way, but it is the derivative. Let's go on to the next one. Okay, I want you to just try this one on your own. It's similar to the last one. Just go ahead and pause the video, give it a try, and then unpause it when you're ready to see me explain it, see if you did it right. Okay, I'm going to start by just breaking this apart. This is the same thing as the natural log of x plus 1 minus, and remember this is like a 1/2 exponent, which I could put out in front. So minus 1/2 the natural log of x minus 2. Okay, even though this looks like chain rule, and it is technically chain rule, the derivative of what's on the inside is super simple. Think about it. Derivative of x is just 1. Derivative of 1 is 0, so I don't really have to concern myself with chain rule here because it's just a 1. Same here. It's just 1 minus 0, so I don't have to worry about that. So the derivative is 1 over x plus 1 minus 1 over 2 times x minus 2. Alright, see you guys in the next video.